Hey guys, and welcome to the Unit 3 test review, sort of how-to video. What I'm going to do here is I'm going to walk through each problem in the Unit 3 test review, step by step, so you can follow along. Hopefully after watching this, and then maybe having, our official review day on Friday, that we will sort of get a good grasp of what's on Unit 3 test, and we can all get mastery of all these outcomes. So, wrap that. We see that we have outcome 9. Outcome 9 we have not tested on, we have not seen, and that's just because it is something that is really simple to do, and I didn't feel like it warranted an entire lesson on it. So outcome 9 is being able to algebraically or graphically solve a system of equations consisting of linear and nonlinear. And so the reason why this is special is because we have a nonlinear, this is a quadratic, so it's not a line graph, and then we have a line. So basically you're going to have a parabola crossing a line. So we want to find out where these cross, where are the solutions. So essentially anytime you want to find where one thing crosses another, you set them equal to each other. So you could do this algebraically, though I don't think most of you are going to do that, but I can just set these equal to each other, and then whatever I find out for x, that'll be where these points cross. So I just set them, so they're both equal to y, so I can set them equal to each other. So I can just have x squared minus 4 equals negative x plus 2, and essentially just solve for x, which ends up turning into a quadratic. Because I have a quadratic, this would need to move over, this would need to move over. So I'd have x squared and then plus x, and then you'd have minus the minus 4. This would become a minus 2, so I'd have a minus 2 and a minus 4, or minus 6. And so you would just solve the quadratic. You can factor and solve it. You can use quadratic formula. I don't think that most of you are going to do that. I think most of you are going to use your graphing calculator. And so what you can do is just put both equations into your graphing calculator and use the intersect feature in your graphing calculator. So I'm going to pull up the graphing calculator here. So here's my graphing calculator. And so what we can do is just put both of those. Let me erase this stuff here. Put both of those into the graphing calculator. So I have y equals, and I'll just do x squared minus 4. And then I will, in y2, put negative x plus 2. And so when I go to my graph, you'll see that I have a parabola and a line crossing. So I'm going to go ahead and draw this. Now, let's find the intersect points first. You can see that this actually intersects in two different spots, one on the left and one on the right. So the calculator is able to find these intersect points by simply just going to the calculate menu. Remember, this is sort of where we always go, to this calculate menu, and you'll see that there is an intersect option. By selecting intersect, all we do is just put the cursor near the intercept we have to find. This is really simple. Okay, all I need to do is put the cursor near it and hit enter once, hit enter twice, hit enter a third time, you hit enter 3 times, and there it is. It crosses at negative 3 and 5. All I have to do is put the cursor near the intersection and just hit enter 3 times. And it will find the intersection of those 2 points, which are 2 lines, which is negative 3, 5. So I go to negative 3, 5 over here in Notability. 1, 2, 3, 4, 5. And so I know it crosses right there. I also can see it probably crosses at 2, where x is 2, but let's just verify that. Second, trace, intersect. Now I want to find the other one, so I'm going to just put it closer to this one. Doesn't have to be on it, just somewhere near it. Enter, enter 3 times, and there you go. It does, in fact, cross at 2, 0. So it crosses right here. And so now I just want to finish and complete this graph. So let's do this in 2 different colors. So the parabola, I'm going to draw, actually, let's just match the colors. I'm going to do the parabola in blue. It does look like it has a vertex or a y-intercept there at, and we should be able to find the y-intercept, it's -4. So it does look like it crosses at -4. So I can draw my parabola. I know that it's going to go through both of these points. So there's that. That is a terrible parabola, but you get the point. The other one is in red. This one's real easy because it's just a line between 2 points. Help me straighten that out. That is terrible. Let's try that again. That's a little bit better. And there you go. I just matched, all I did was find the intersect points using my graphing calculator and then drew them on the graph. And there you go. Mastery. So that's how you do that one. And we can go over another example of this on the review day if you want. But that's how we do those problems. Now on to the problems that we should know how to do, and that's outcomes 10, 11, and 12. So in these outcomes, in outcome 10 is being able to convert it from standard form to vertex form. So on this review, the only one that you have to convert from standard form to vertex form is number 3, because number 2 is already in vertex form, so that one wouldn't apply to outcome 10. Both of these apply to outcome 11, which is being able to graph them algebraically, meaning you have to find the vertex algebraically. You have to find another point algebraically, and then you have to know that parabolas are symmetrical to put a mirror image of that point on the other side. I don't need the calculator, the graphing calculator right now, so let's focus here, and let's look at number 2. Number 2 is already in vertex form. Vertex form, again, is y equals a. Ooh, there's a typo. That's supposed to be an x. There's an y equals a, parentheses, x minus h squared plus k. Remember that your vertex is your h and your k, which matches up here. Now, excuse me. One thing that we have to keep in mind is that the formula has a negative sign in it, which means that our vertex is simply just h and k. But because of this negative sign here, we have to keep in mind that this is actually an opposite sign. So when we go to pull the vertex out of here, I have to remember to change this sign because of the negative in the formula. So the vertex here, vertex is simply positive 2 and then 1. So on my graph, I can go over here, go to 2, 1, and there will be my vertex. Okay. Because I know my vertex, I will also know my axis of symmetry, which is just x equals the x value of that vertex. All that is an imaginary line, and I completely forgot that we have dashed lines here. So I can just go like this. I don't have to make dashed lines. But there's my axis of symmetry. You want to make sure that you do, in fact, label those. I don't need to label the axis of symmetry part. I will know that a dashed line is there. So the only thing that I need with number 2 is I need another point. Now, unfortunately, it's not in standard form. See, if the equation were in standard form, then I would have my y-intercept. Because this is not in standard form, I don't have my y-intercept, so I have to find another point. It doesn't matter what point you use, just pick any x value that would fit on this graph. Since we have 2 already, maybe choose 3 or 4, or maybe choose 0 for x. It doesn't matter. I think 0 is probably an easy one to do for x. So I'm going to use 0. So let's do this, and let's change colors here. I'm going to plug in 0. And you could choose any x value. It doesn't really matter to plug it in. So what I'm going to do is, here's my point, 0, and I don't know what the y value is. So 0 is going to go in for x. So I get y equals negative 1/4, and then 0 minus 2 squared plus 1. Now, 0 minus 2 is negative 2. Negative 2 squared, we have to remember our order of operations. Okay, negative 2 squared is 4, so essentially I have y equals negative 1/4 times 4 plus 1. Well, negative 1/4 times 4, or negative 1/4 of 4, is just negative 1. So I get y equals negative 1 plus 1, or y equals 0. So it does look like that if I plug in 0, I get 0, meaning that 0, 0 is an actual point on my graph. So we go over here, 0, 0 is a point on my graph. Using the fact that parabolas are symmetrical, I will have a reflecting point across the axis of symmetry on this side, and I have all 3 points needed to graph, so I can graph my quadratic. And it seems to be that simple. But I understand there's a lot going on there. But basically, if it's in vertex form, you just plot the vertex right here. Because I'm not given the y-intercept, I have to do a little work here. So I just picked a random x. I just picked 0. Plugged it in, found out what y is. So found out that 0, 0 was a point. Plugged in that point, knew that there's a reflecting point on the other side because of the symmetry, and then was able to graph it. Now, number 3, the work here has to be done on the front end in that in order to find the vertex, I have to convert it to vertex form. This is actually outcome 10 and 11 in this problem, whereas number 2 is just outcome 11. Here, I have to change this into vertex form. So remember what I told you, if it just says y equals, simply just ignore that and set it equal to 0. Now, in order to do the conversion to vertex form, the negative 2 will have to go to the other side. So I have 1/2 x squared plus x blank for when I complete the square, and a positive 2 on the other side. All right. Now, because I have this number in front of my x squared, I cannot complete the square. I need to find out what goes here, but I can't yet because I have this 1/2. So what we do to get rid of the 1/2 is simply just divide by 1/2. Divide by 1/2. Might be handy to know that there is actually a 1 right there. The 1/2 that you divided out goes out front of the parentheses. So now I'm left with just x squared. Now, I have to do 1 divided by 1/2. In other words, how many halves go into 1? Well, it's 2, so it's 2x. And then I have my blank, n equals 2. Now that I have that 1/2 out of there, now I can complete the square. Essentially, I need to figure out what goes right there. Remember that you take, to complete the square, you just take half of your b, half of this number here, and square it. Half of 2 is 1. 1 squared, or 1 times 1, is 1. So plus 1. Now, before you go adding 1 over to this side over here, we have to remember that whatever we add in here, if there is a GCF, these do need to be multiplied. So I do have 1 times a half, which is actually a half. I do have to add a half over here. And then now I can put this in factored form. The number that multiplies to be 1 and adds to be 2 is simply just 1 and 1. So I can write this as x plus 1 squared. 1/2 comes down. Now, 2 plus 1/2 is 2.5 or 2.5. That 2.5 will need to go back over to the other side, minus 2.5. So now that this is in standard form, in vertex form, now I can plot this on a graph. So my vertex, I do have to label my vertex here. My vertex is going to be your h and k. Don't forget that the h has to be opposite signs, so it's actually -1, -2.5.
Good morning, staff. I have
Sorry.
one announcement. Anyone everyone who signed up for pickleball will now be meeting in the main gym. Again, pickleball will be in the main gym. Have a great time.
Sorry about that. -1 and -2.5. So -1 and -2.5. -1, -2.5 is somewhere right here. And then I have my axis of symmetry. A of s is x equals that x value. So I have a dashed line that will go right through those. Right through that vertex. There we go. And then now here's the easy part. Since the equation was originally given to us in standard form, I have the y-intercept, and why it's a dashed line, I don't know. Okay, standard form gives us the y-intercept of -2. So I can go down here and see that my y-intercept is -2. I will have a reflecting point on the other side to complete the requirements to graph this parabola. So it goes something like that, and something like that. And there you go. That's graphing parabolas. That's outcomes 10 and 11. Moving on to outcome 12. Outcome 12 is now we're given nothing but a couple points, and we have to come up with the equation. Now, unlike the previous one, we don't have to actually graph these, but we do have to find the equation. Now, you can write your equation in standard form, vertex form, or intercept form. It all really depends on what they give you. But since they're giving you it in vertex form, I highly recommend that you use vertex form since they're giving you the vertex. Vertex form, if you remember, is y equals a x minus h squared plus k. So, we simply, since this is h and this is k, we simply just take our h, plug it in, take our k, plug it in. Now, don't forget that when you are putting things in this formula or taking things out, the sign will change because of the negative sign. So when I go to write this formula, y equals a x, it'll now be positive 4, and then plus k, which is 2. Now, I'm not quite done. This is essentially my formula. The only thing that I need to find is a. Now, what I told you guys in class, that is where the other point comes from. This other point over here that we were given, it's there for a reason, and that's to help you find a. Since we don't know what a is and we need a, we can use the x and y that are given to us right here and plug it into the x and the y in our equation to find a. So y is -4. I don't know what a is. X is -6 plus 4 squared plus 2. And you simply just solve for a. -6, we got to do our order of operations. -6 plus 4 is -2. -2 squared is 4. So essentially I have -4 equaling a times 4, or 4a plus 2. I keep going with this. Okay, so -2, -2. I have -6 equaling 4a, and then divide by 4, divide by 4. And what you'll get is -3/2. A equals -3/2 when we reduce 6/4. -6/4 reduces to -3/2. So now I can take this and I can plug it into the a. And so my formula, let's write this in a different color. My formula is now y equals -3/2 x plus 4 squared plus 2. Actually, that would go right there. But there's the formula using vertex. Okay. Now on to outcome 13. Outcome 13 you've not had a quiz on. We just learned outcome 13 in the last class. This is where our graphing calculator is going to come in. So I'm going to bring this up again. Bring up our graphing calculator. Okay. Let's clear out of there. Okay. And so if you remember, this is modeling quadratics. So when you're modeling quadratics, you need to use the graphing calculator to help you find different points within an equation, real-world points. So here's the flare problem again, kind of a visual of the flare problem again. So here you can see a boat. They shot up a flare, It follows a parabola. And so you're going to just kind of pick out the information from there. They start off really simple. So what's the maximum height of the flare? That should be pretty simple. It's right there, the top point of the graph. I don't think that's a challenging issue for anyone here, but it is 196 feet. It does say that the units are in feet and time is in seconds. What time does the flare reach its maximum height? Well, that is just simply the x value now. So 3.5 seconds it looks like. So bell, because it's 8:58. Approximately how far will the flare travel? Again, I don't know why they keep doing this in typos. This is not how far. This is supposed to be how long. Let me make sure I fix those. How long will the flare travel? So you look down here. It looks like it hits the water at 7 seconds. Hey, those ones are easy. They're on your test. They're on your quiz. So we want to make sure that we get those ones right. The next model here is now they're giving us an equation and we need to figure out all this stuff. So before they gave us the graph and we had to figure out the information. That's the easy part. But now when they give us the equation, we have to get the graph because we need the graph to find the height and how far it goes and all that stuff. So this is where the graphing calculator comes in. So I can plug this into my graphing calculator. Let's clear all that stuff out. So I'm going to put in, now I know it says t's. Your calculator does not have t's, it just has x's. So you're just going to use x's where you see t's. So it starts off with negative 2t squared, so I'm going to do negative 2x squared plus 2x and plus 55. And so when we graph this, obviously we can't see this. I need to go higher on my graph. So one of the tools that you can do is change your window. Right now my window is 10 by 10, but I need the y value to be higher. Right now the y only goes up till 10. My motorcycle goes up to a height of, the y-intercept is at 55, so I need at least that. So you can click on window, and I need my y value to be taller. So my y max, I don't want my y max to be 10. I want my y max to be higher than that. Since I know that the y-intercept is 55, it should be higher than that. So let's just try 60. But now when we hit graph, it just stretches the y-axis up so that I can see the whole graph. So now that I can see the whole graph, let's find all the information that they want. So the first thing it says is, what height did the stuntman jump from? Well, you have to understand what it's all talking about here. Where it jumps from is where he's going to be starting his jump. So the starting point will reference the y-intercept. Because the y-intercept is 55, that essentially is going to represent where he left the ramp. So the height that he jumped from would have been 55 feet. Now we want to see what time the motorcyclist hits the ground. Essentially, we want to find where our parabola crosses the x-axis, because think of the x-axis is the ground. So the parabola is his path, the x-axis is the ground. We want to find where his motorcycle hits the ground. In other words, we want to find the x-intercept. Now, we already did this in previous units on finding the x-intercept, and that was second and calc, and we go to 0. From here, we want to find the x-intercept, so we need a left boundary. So here's where I want to find out is where he hits the ground. So I want to make sure I go a little bit left of that, hit enter, a little bit right of that, enter, and enter again. And so what this finds is where he actually hits the ground and what time he hits the ground. And it looks like it's 5.77 seconds. But you're going to use the calculator to find all these information. I could also find the highest point that the motorcycle, because think about a motorcycle going off of a ramp, he's going to go up a little bit before he starts coming down. So I could find the highest point here by also using second and calc and just going to maximum. Now the maximum is going to be at the top, so all I got to do is just set the boundary left of the top and right of the top and hit enter a third time. So I can see that he started at 55 feet, but His highest point was only 55.5 feet, so it looks like he only went up a half a foot before he came back down. The last question here is going to be to interpret this graph when you don't have all the points. So here's a flu epidemic. It's no sheer coincidence that we're going through a pandemic right now. But this is a flu epidemic. So over the period of 12 days, you can see how many students at a particular school got the flu. And so you can see it sort of peaked there at 19 students on day 6 got the flu. And then it goes back down. But so the first thing we need to do is find the equation of this. The problem is we don't have another point. So it looks like at day 0, at time 0, we actually had 1 student. So you have to remember how parabolas work and that parabolas are symmetrical. So in order to find the third point, because remember you need 3 points to graph a parabola. Well, that didn't really work out as far as a straight line or straight up and down line. We have to know that we have a point over here that is mirrored. So it looks like it's going to be 12, 1 would be the mirrored point. So now that we have all 3 points, we can run quadratic regression to figure out the equation. Now the first question just simply is talking about the vertex. What is the meaning of the vertex? Well, since the vertex is the maximum point on here, you could imply that the maximum number of students that had the flu or got the flu would be 19 students. So you could say max students sick per day is 19. Something along those lines. Or it's the most amount of people that got sick during the flu epidemic at the school. It's not really an epidemic at just a school, but that's just, some meaning of maximum students or the most students per day, something like that would reference that, the vertex. Write a function. This is where our calculator comes in. We did need that third point because in order for our calculator to calculate the quadratic regression, we do need 3 points. So we want to go to stat and edit. Sorry for all the bells. And 0 and 6 and 12 are our x values. 1 and 19 and 1 are our y values. And so we go to stat and calc. And this time we're going to go to quadratic regression to find the equation. Now it gives it to us in standard form, ax squared plus bx plus c. So we simply just write the equation. Y equals a is negative 0.5, x squared, b is 6, and c is 1. And so there's our function. Use your equation to estimate the number of students on day 9. We simply just take 9 and plug it in to these x values to find how many students were sick on day 9. Y equals negative 0.5, 9 squared, plus 6 times 9, plus 1. Why is it not writing? There you go. And then we do our order of operations here. 9 squared is 81. Negative 0.5 times 81. There is negative 40.5. Then we have plus 6 times 9. 6 times 9 is 54. Plus 1. 40.5 plus 54 plus 1 equals 14.5. So on day 9, 14.5, well, I would say round it. So 15 can have 14.5 kids sick. So about 15 kids sick. And there you go. There's the review from start to finish. Hope this helped. We'll have an actual review day on Friday.